Okay, that's really good. Children, can you see the screen properly? Okay, children, hi there. Welcome to the live session on matrices. What we are going to do today is the most important part to the ISC board point of view, because one question for 6 marks is going to come on this rule, which is called as Martin's rule. Okay, it is called Martin's rule. Now, basically, what is this Martin's rule? I'll just share with you very nicely, because in this case, if you see carefully, this rule is nothing but it's clearly specified here. It's clearly specified that application of matrices for solving system of equations. Now, this is a very, very important word, which is nothing but called a system of equations. System of equation means simultaneous equations, not one equation, not two equations, but more than two equations and less than four. So, whenever you want to solve three equations, you can always use the Martin's rule, which will always be helpful to you. Okay, so this is one of the very, very important part and the last part of matrices, because on this one question, question number 12 in the board paper comes for 6 marks, children, comes for 6 marks, keep that in mind. So you can't afford to lose out one question for 6 marks, it's really for grab. Now, what is important for us to understand is what is Martin's rule. So, Martin was a mathematician who suggested this method for us. Okay, remember what we have done in matrices? We started with transpose, then we went into symmetric, we went into skew symmetric, and then also finally we saw what is the adjoint of a matrix. Then we went for inverse of a matrix. Now, all these things we are going to use to solve Martin's rule. How I do it, when I do it, all those things will come up. But before that, a very good point I want to start with it. That is nothing but, if you see carefully, I want all of you to take down this particular chart, which is really, really very, very important. Because this gives you a guideline to go by which way you have to solve and find the solution of the simultaneous equation. So children, please note it down. I want you to take down this equation properly, this chart properly. It is given system is equal to AX equals to B. If you see carefully there, system, you can see this part carefully. System is equal to AX equals to B. Find determinant A. If determinant A is not equal to 0, it is a unique solution. X equals to A inverse B, consistent. If determinant A is equal to 0, find adjoint A into B and the chart. Please take down this chart. I give you 3 minutes for taking it down. No mistake. And then I will come and explain to you exactly what I mean. Please take it down. I'll take it down quickly, children. Okay, when I do the sums with you, you will understand what I am trying to tell you. First, any equation which is given to you, you are going to use, if you see carefully, Martin's rule is nothing but application of matrices for solving system of equation. Okay, so here the chart happens to be A equals to B, system of equation, find determinant A not equal to 0 and so on. I come back to this chart again and again, we are doing the question, so you will be better equipped for that. Okay, did you finish? Good. Right? Okay. Let us get into the questions now. Okay, now I just tell you what does that mean. Please pay attention now. System of equation has to first step for any. See, if you see the question is like this. Using matrix method solve. So solve using matrix method solve. It means that is this are the two equations which is given to you. 4x minus 3y equals to 11. 3x plus 7y equals to minus 1. Now you can do this by simultaneous, but they specifically told you that use matrix method. So how I do that? I take you back to the chart. First thing, any equation is given to you. You have to write in this format, Ax equals to B format. So what is Ax equals to B format? I'll just tell you. Now see how I write this matrix in matrix form. Ax is equal to B format. Now, what is A? This is A, this is X, and this is B. What is A? A is nothing but the coefficient matrix. Now, when I say coefficient matrix, coefficient is 4, 3, minus 3, 3, and 7. So, this is the coefficient matrix. So, for this side, what is the coefficient? 4, 4 minus 3, 3 comma 7, x comma y. X is the unknown matrix is equal to 11 and minus 1. Now I want to show you something very interesting. Let us see what I am showing interesting. If you multiply this, what happens? Let us see. 4 into x minus 3y. 4x minus 3y. 4 row into column. 4x minus 3y equals to 11. Similarly, second row and the column 3x plus 7y is equal to minus 1. Now look, these both are same equation. So in short, what I want to tell you the message, children, that this particular matrix, this particular equation, you can write in matrix form. So how I write it? It is always Ax equals to B. So that's what exactly I planned out. You write the equation as Ax equals to B. Any system of equation, whether it's a 2 equation, 3 equation, whatever it is, write the system of equation in this format, Ax equals to B. Right? Now what happens after I finish writing this part? Now I want to find x and y. That means I want to find the unknown matrix. This A is called coefficient matrix because it carries the coefficient, and B is called the constant matrix because the constants are put in this particular. So all the sum has to be written like this now. Now what is the next step? Next step is, if you see, after writing the system, they are telling us find determinant A. What they are telling us to find? Determinant A. So what happens to determinant A? Let us see. First, let us find determinant A. So determinant A will be AD minus BC. So whatever we studied in the previous part in matrices, all those things are going to be used here. Okay. So 7 4s are 28. Minus of minus 9 is plus 9, 37. As determinant A is equal to 37, hold on, it is not equal to 0. I want to take you back to the chart. Look at this. I found determinant A. There are two options. You find determinant A, it will be either a zero value or a non-zero number. So look, if determinant A is not equal to zero, it has a unique solution. And what is the solution? What is the solution, children? The solution is x equals to A inverse B. The solution is x equals to A inverse B. Because determinant A is equal to not equal to 0. So as I said, what happens now is determinant A is not equal to 0. Therefore, I can say unique solution. Unique solution का मतलब है one value for x, one value for y. And what is the solution? The solution is x equals to A inverse B. So let us begin. A system of equation is given to you. A system of equation is given to you. You write the system of equation in matrix format. Find determinant A. If it is not equal to 0, then x equals to A inverse B is the solution. So my solution will be x is equal to A inverse into B. I know B matrix, but I don't know A inverse. So first find A inverse. So how I find A inverse? Let us see A inverse now. Now you know A inverse is equal to 1 upon determinant A into adjoint of A. Do you agree with this? This we have studied already, right? So A is equal to, it is 2 by 2 matrix, so very simple. 1 upon determinant A. What is determinant A? 1 upon 37 into adjoint of A. Tell me, for a matrix, I told you a shortcut method to find adjoint. What was that method? This diagonal you swap. These two numbers, keep it as it is. This diagonal element, keep it as it is, but opposite side. So 3 minus 2. So this is my inverse matrix. Okay. Now come to the main solution. So what is the main solution? X is equals to A inverse into B. So x is the unknown matrix. So x is equal to A inverse. So 1 upon 37 into 7, 3 minus 3, 4 into B. What is my B? 11 and minus 1. 11 and minus 1. Now solve it. That's all. So let us see now. So x will be equal to 1 by 37. Now let us see what happens. So look at the pattern here. 7 11s are 77 minus 3, 74. This मांगे more. Minus 33 minus 4 minus 37. Now this 74 divided by 37. This eventually will be 74 divided by 37 will be 2 and minus 37 upon 37 will be minus 1. What is this? This is X matrix. And what is X? X is nothing but X comma Y. So in short, I can say XY is equal to 2 and minus 1. So tell me now, what is the value of X? X value is 2 and Y value is minus 1. This is what solving these two equations. I call these two simultaneous equations not by algebraic method but by matrix method. Remember, that's why this chart is very crucial. This chart is very crucial. If you see this chart is very crucial here. Very crucial. So in any equation, first to write the equation in matrix form. Then find determinant A. So once you find the determinant A is the value. If the determinant A is equal to 0, you go there. If determinant A is not equal to 0, you come here. You come here. So determinant A is not equal to 0, so it has a unique solution. What I would say, it has a unique solution. And what is the solution? Solution is x equals to A inverse. So I did this part right now. Using matrix method, I converted to matrix form. I wrote Ax equals to B. then I find determinant A, because once you get a determinant, you know whether to go this way, whether to go this way. So determinant A is equal to 37, not equal to 3. So what is the solution? Unique solution, x equals to A inverse. So I got the solution here, that is A inverse is equal to 1 upon determinant over Shiva. I got A inverse. Once I get A inverse, I know what x stands for. X stands for A inverse. You must know from where you got it. I got it from here. Just see how. Ax equals to B shortcut. You don't have to show it. I'm just telling you. Okay. Pre-multiply by A inverse on both the sides. So A inverse A into X equals to A inverse into B. What is A inverse A? I into X is nothing but A inverse B. So X is finally A inverse into B. So that's what I got the solution directly. You don't have to show this in the exam. If determinant is not equal to 0, this is the solution. That's why this chart is very crucial. If determinant is not equal to 0, the solution is this. But if determinant becomes 0, then you have to find adjoint A into B. Because based on that, the conclusion is there. Either it has infinite solution or it has no solution. We will come to that sum when the time comes. But right now, in my case, I know that determinant is not equal to 0. So I solved it out. I got A inverse. I used this A inverse in the final solution. So first, second step, third step, fourth step, fifth step. So this is the way I solve a simultaneous equation by using the matrix method. I hope you got this point clear. So just cheer up, jack up. One more question we will do on this, okay? And enjoy the lecture. Okay? Please take it down. Hello. Okay, Dimna, are you done? Give a thumbs up now on the group. Give a thumbs up if you have finished copying down. I'll take the next question also. Two thumbs up, one for finished writing and second is for the live lecture. I want some encouragement. Really, is it clear? Is it audible? And do you feel it's very nice at your end? Don't worry, in the next week, a better defined projection is coming. It will be more clearer. I will be more clearer to you all. Don't worry about it. Okay, but I want double thumbs up. Is it only one single thumbs up or double? Okay, let's take the next question now. Alright, this is a big question now. I want you to pay attention now. They are telling A is equal to, like, fine. I think they are telling something like this. So, 1 second now. I just want to see where is that. Okay, no problem. Right. Now, what I'm going to do is I'll just work out properly in front of you and see how we go about that. Okay, just a second. Now, look at the question carefully. If A is equal to 3 minus 2, 1, 2, 1 minus 3 minus 1, 2, 1, find A inverse. Okay, okay, find A inverse. Okay, find A inverse. Fine. Now, pay attention now on this question. First question, if you see this question, there are two questions. First is find A inverse, and second is hence solve this equation. Hence solve this equation. Anyway, now what I will do is, just because of a little bit short of time, I will just solve this directly. Okay? So this you don't consider now. Please don't consider. Okay? I'm just solving directly this sum with you. So pay attention to the previous procedure so that you adopt to that method. Don't worry, we'll do lots of questions because this question is surely going to come for 6 marks. So you can't play a game here. More questions will solve in the coming. First thing, an equation is given to you. First, write it. If you see carefully here, if you write it in matrix form. So, what is the matrix form? Let us see. So, matrix form A X is equal to B. Okay. So, I'll just mark some red zone here, so that you come to know how to go about that. Okay. Now, once you finish with this, children, let us see how we go about it. This is A, this is X, and this is B. This is the coefficient matrix. So, write the coefficient. 3 minus 2, 1. 3 minus 2, 1. 2, 1 minus 1. 2, 1 minus 1. Then minus 1, 2, 1. Minus 1, 2, and 1. This is nothing but unknown matrix is always a column matrix. X, Y, Z is equal to the constant matrix 2 minus 5 and here it is. If you multiply my children, if you are going to open this up, you are going to get the same equation. You are going to get the same equation if you open up. So what I am trying to tell you is a simultaneous equations can be written in matrix form. Now, if I go further with my chart, after I wrote the system of equation, what I am going to do? I am going to find determinant A. What I am going to do? I am going to find determinant A. So let us find determinant A now. So determinant A will be 3 arbiters AB minus BC. So 1 plus 2, 3. Minus of minus plus 2. I am using the first 2 and expanding it. Okay. 2. 2 minus 1. That is 1. I hope let us see. 3 AB 1 plus 2, 3. Minus of minus 2, then 2 ones are 2, minus 1 is 1. Plus C, 1. 4 plus 1, 5. So I got how much? 6, 7, 8, 8 plus 5, 13. 8 plus 5, 13. So let me just confirm at my end, children, so that there is no mistake at my end. 3 minus 2, 1, 2, 1. Oh. Sorry. I did a mistake here because it's 2, 1 minus 3. Sorry. It's 2, 1 minus 3. So this will go up now. 1 second. Not a problem. It happens sometimes. Now look at this pattern here. So determinant A, as I said, determinant A will be 3 into 1 plus 6, 7 plus 2, 2 minus 3 minus 1, then plus 1, 4 plus 1, that is 5. So I think I'm very clear about it. 3 sevens are 21, 21 plus 5, 26 minus 2 is 24, not equal to 0. I see once you get the determinant value, you have to go back to the chart. Determinant A is 24 in this case, 24 not equal to 0. That means what is the solution? X equals to A inverse. What is the solution? X equals to A inverse B. So A inverse. Now you know that A inverse is 1 upon determinant A into adjoint of A. 1 upon determinant A adjoint A. You remember how we did adjoint A? What is the adjoint A? A11, A12, A13, A21, A22, A23, A31, A32, A33. Please understand what I am trying to show you. Now A11 is there. So A11, this is 7, this is minus 1, and this is 5. 2, 1 comes here. 2, 1 come to this element 2, 1. So minus 2, minus 4. I hope you remember adjoint A how we did it. 2, 2 is here. I repeat once again, minus 2, minus 4. 2 is here. 2 is here. So 3 plus 1, this is 4. 2, 3 is here. 6 minus 2, 4. Oh my God, 4. Chowkla ke upar chowkla. 3, 1 is here. Minus 1. That is 6 minus 1. That is 5. 3, 2 is here. This element I am talking about. 3, 2. That is minus 9 minus 2. Minus 11. And 3 is here finally. 3 plus 4. That is 7. Now hold on. Adjoint is transpose of cofactor. How I find cofactor? Plus, minus, plus, minus, plus, minus, plus, minus, and plus. So A inverse is nothing but 1 upon determinant which I just now found into adjoint of A. Adjoint of A, remember this working. 7, 1, 5, 4, minus 4, and 5, 11, 7. 5, 11, 7. Thank God I got my work done. Now there is a problem. Now in this case, if you remember, what is the solution? As determinant A is not equal to 0, the solution is x equals to A inverse into B. X equals to A inverse into B. X equals to A inverse into B. So x is A inverse, I got it, 1 upon 24 into 7, 4, 5, 1, 4, 11, 5 minus 4, 7 into B. Now look, what is B matrix here? B matrix is here. 2 minus 5, 6. 2 minus 5 and 6. That's it. My game is over. X equals to 1 upon 24. And solve this now. See, 7 twos are 14. Minus 20. Hold on. 7 twos are 14. Minus 20. Minus 6. 5 6 are 30. 24. 1 twos are 2. Minus 20. Minus 18 plus 66. So 66 minus 18. 16 minus 8. 8. 48. Similarly, 5 to the 10. 10 plus 20, 30. 7 is the 42. 72. Wow, 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 wow. What is that? That is nothing but 1, 2, 3. And what is 1, 2, 3 is x. But what is x? X is nothing but x, y, z. So x is 1, y is 2, z is 3. So that's the basic part of it. That is, if I have the chart in front of me, if I have the chart in front of me, children, find determinant A. Determinant A not equal to 0. This is the solution x equals to A. So in short, I didn't do anything different. I got determinant A. Therefore, this is the solution. Remember this. But A inverse के लिए, what is A inverse? A inverse is 1 upon determinant A into adjoint of A. Don't you think it's really a great thing to do like this? Yeah. So working 6 marks, not a joke. 6 marks, not a joke. 1 mark for this, 2 marks for this, and 3 marks for solving. So in short, I can say from here that is x is equal to 1. Y is equal to 2 and Z is equal to 3. This is my solution which is coming up. Children, I hope you understood this point, but we will practice lots of questions because the 6 marks are really not going to leave. I'm going to snatch it up. So 6 marks is mine. Remember this. जोश से नहीं, होश से काम लेना आपको. जोश से नहीं, होश से काम लेना आपको. So I hope you got this point clear. You just take this down properly, children. Note it down. Otherwise, I will. Got this point clear? Take it down in a better way. We will continue with the live sessions now. The next lecture, children. More sums will come on this pattern. So more again and again you will revise adjoint कैसा निकालना है, inverse कैसे निकालना है, how to solve the simultaneous equation, by using the matrix method. Keep that in mind. So I hope you got this point, the children. So please note it down, and with that we end the lecture. The screen will be visible for next 3 minutes. Sorry to give you less time. Today was a little bit problem. Vedant Dora, apologies, because I didn't see that you are waiting in the room. So definitely I'll let you in as soon as I feel that you are already there in the room. Okay? So please take it down, children. Thank you very much for being with me and really encouraging and inspiring me to do more and more things. Once again, I want to promise you, you will find a better view than this in the coming week, in the coming sessions, so that the more advancement in teaching learning process can happen. So please note it down. And thank you once again for being with me. God bless you all. Take it down quickly.